Hi everybody. My seminar is titled Life is a Balancing Act, and you will shortly understand why. I am Valentina Bosetti. I teach at Bocconi University and I work at Fondazione Enrico Mattei. And what I do is called climate change economics, which means trying to understand with economics how to solve the climate change problem. So I have been working for some time at a report which is available online, and it's called the IPCC report. And I think I wanted to start with this because it is where all the research and everything that we know about climate change economics is condensed. The IPCC report collects all the science that have been produced so far on the science of climate change and climate change economics. It is divided in many chapters, and many scientists and economists have worked to it. And what is interesting about that is that many people coming from different disciplines have been trying to look at the problem from their own angle, and then at the meeting where the report was written, tried to communicate and talk to people from other disciplines. So not only it's an exercise of science, but it's a kind of exercise of democracy where different voices have a space. In addition to scientists, the attempt is to cover, in addition to cover all the different disciplines, the attempt is that of covering also different countries in the world, so that scientists from developing countries as well as fast-growing countries and developed countries can have their own voice. So most of what I present in the rest of the presentation is not just what I do, but is part of this report, and so it is the product of a large collective effort. So I think I'll start of why climate change is related to what we do, which is the first piece of the puzzle. So to clean the room from any suspect, climate change won't be solved on its own terms because of a lack of fossil fuels. So in the graph that you see, in blue you see what we have, in dark blue you see what we have already extracted and burned in terms of gas, oil and coal. In light blue you see what we're going to burn and put in the atmosphere in the next century if we keep going the way we've been going. And in yellow you see what's still in the ground, recoverable. So what this picture is telling you is that unless we do something, if we keep burning, there will be stuff to burn. So have we been doing any better in the past 30 to 40 years? From this graph, what you see is that the trends have been increasing. So we've been burning more greenhouse gases than we were burning before. The different colors tell you from where the emissions are coming from, and the total is the total greenhouse gas emissions. And if you look at the trends in the last 10 years, well, the increase per year of emission is 2.2 rather than 1.3, which was in the period before. So even though we now know of the problem, we have been burning and releasing more greenhouse gases than before. So the problem will not be solved on its own, and even though we have known about the problem since some time, we haven't been doing much so far to solve it. So where do these emissions are coming from? This decomposition that I'm showing in the graph gives you a sense of the different sources. So you can decompose emissions in different parts. One part is the fact that we become more on the planet, so we'll need more energy, and that will imply more emissions. A second component is the dark blue component, which is we're becoming richer per person. And this is a good thing, but the more rich we are, the more we emit. And then there are two other components. One is how much energy is required to produce the wealth that makes us consume and eat and everything else that we do. And the red part is how much emissions we produce for 1 unit of energy. So, for example, if instead of producing our energy using coal, we start using gas, the emissions per unit of energy will decrease. So what you see is that in the past, the increase in population and decrease in GDP have mainly contributed positively to the increase in emissions, whereas the change in the energy intensity and the carbon intensity of energy have been contributing in reducing emissions. This has changed in the last 10 years. How so? Even though energy intensity have been decreasing as in the past, carbon intensity have been increasing, have been contributed to the increase in emissions. And this is mainly due to the increase in consumption of coal in China. So we've seen 3 things so far. We have a lot of fossil fuels underground, and so that means that the problem won't solve on its own. And we have been increasing emissions, so recent trends are worse than in the past, and most likely the cause of this is the fact that we are burning more coal than before. Now, is this a problem? Are we sure? Is the science settled on the fact that this is a problem? What I'm showing you in this picture is the relationship between how much gas is in the atmosphere. We call this greenhouse gas concentration. So how much gas is in the atmosphere and stays there. And on the other axis, you have the temperature increase. When I talk about temperature, and when scientists talk about temperature, they typically refer to the average temperature on the planet. So you have to imagine that the average temperature is something that doesn't really exist. It's the average of the temperature in different parts of the planet. So if I'm talking about a 2 degrees Celsius increase in average, it could be that at the poles, this is actually 7 to 8 degrees Celsius. So it is the average, taking into account of various different levels of change that might happen at different latitude. So again, to go back to the graph, what you see is the concentration and the relation with the temperature increase with respect to what we had before the Industrial Revolution, so before we started to emit fossil fuels in the atmosphere. And what you see is that the relationship, though uncertain, is kind of clear in its positive terms, which means that increasing greenhouse gas emissions in the atmosphere will result in an increase in temperature. We don't know with 100% certainty how much the temperature will increase, but we know the range and we know it will increase. So when you hear people saying that there is a lot of uncertainty about this, it's true. Science is always working on a better estimate and always refine the judgment and the numbers, but science is now settled on the positive sign and on the overall magnitude of the effect. So if we keep emitting, temperature will increase. Well, is that a problem? What you see here is what we get from the IPCC report, and it's a sense of what different temperature increases that you see reported on the right. You see today temperature with respect to the pre-industrial reference, and then you see the thermometer that can go up to 5 degrees, for example, and then you see different sources of danger. For example, implication and impacts on unique and threatened systems, or extreme weather events, or distribution of the impacts of climate change effects. And what you see is colors that represent what is the additional risk associated to that level of temperature. So say that we were to increase temperature by the end of the century to a level of 4 degrees Celsius, which is what will happen if we don't do anything about climate change, most likely, then you see that you have a high to very high risks, additional risks due to climate change in basically all the different sources of impacts. So yes, the science is settled. There could be very very important additional risks to various either human or natural related ecosystems and processes. So this is not a nice graph. This is I just draw this graph, and it's just to give you a sense of what is yet to be understood fully. What you see here is on one axis the temperature increase, on the other axis how bad it is. And the smiling face, I guess you get it, is not very bad, and the non-smiling faces it's going to be bad. Now, what is the impacts on agricultural system, forests, and so forth of an increase in temperature? What we find in the huge literature that is out there is that for low increase in temperature, the sun and the increase in temperature are good for increasing crop yields. Not just that, but even the CO2 in the atmosphere helps plants grow. So at low increases, you have a positive effect. As temperatures start to increase above certain critical levels, these are typically around 2.5 degrees Celsius with respect to pre-industrial level, then you start to have a negative impact. So it is good, a little increase in temperature is good, but then it becomes very, very rapidly bad for the ecosystem. And the most important thing is that we don't know how bad. That's why I'm drawing a different red line that is going down towards very bad impacts more rapidly. So not only we do know that it's going to be bad for higher temperature, we don't have a clue how fast this could happen. And this is true for the analysis that have looked at crops and forests, but also true for analysis that have looked at impact on human beings and well-being of populations. And it's also true for analysis that have looked at various different countries. So this is true in particular for countries that are located at the tropics, but it becomes true also for countries that are, for example, located within Europe. So let me go back and try to pull together what we've said so far. We have our actions that compose our daily life, so the way we have fun, we travel around, we eat, and so forth. And this has a byproduct, and there are emissions of greenhouse gases. And this byproduct, we now know, gets stuck in the atmosphere. By getting stuck there, it increases the temperature of the Earth. And we know with kind of certainty, although we are not certain about the magnitude of the impact, that it is going to affect snow cover, ice, and it's actually already affecting snow cover, ice, water, and crops. But then we know that this will have an impact on our lifestyle and how people may be able to develop around the world. But this is why the arrow is lighter, of a lighter color. This is known with yet less certainty. Now, I've discussed why and how we do impact climate change, but let's discuss now what we can do about it. And let's keep in mind a theme that was coming out over and over, how certain we are about that. The first thing that I want you to remember is there is no silver bullet. So I'm not going to tell you, you can do this one thing and then problem is solved. That's why it's a complex problem. So there are many arrows here. We can do many different things. And this, for example, imply the change in the way we produce electricity, the change in the way we get around in cities, and the way we build cities, the way we design the time of our day, and maybe more importantly, the way governments negotiate and define an overall target and then policies to achieve that. And this has a clear impact, and we can with model understand how these different changes in the way we produce electricity, we move around, or in changes in agreements, international agreements, impact or will impact the future of the planet. What is harder, though, is to understand what me and you as a person can actually do to do something about that. So what I show you here are typical kind of actions that we might take to do our own share, and this is we start going around by bike, or we can change our diet and eat less red meat and eat more vegetables, or we can, for example, start to fight for a climate agreement and go out in the streets and demonstrate for that. But the problem with these types of action is that, see that arrow, really you do a lot of effort and you see that the chain of actions that link your effort to the planet gets smaller and smaller. You cannot even see what's happening there. And that is why it is a big problem. Let me give you an example. This is a very important case study. You won't find that on scientific paper, and this is called the low carbon grandmother case study. So we're talking about a grandmother who is switching off the lights. Whatever happens, she probably will get blind because of that. She's using so little to heat her house that she's always cold, and she only goes around by bike. So she's the perfect example of a behavior that could solve in principle climate change. But now what happens when her grandkids move to the United States? In one single year, she's doing 4 trips to the US. Okay, if you do 4 trips to the US, then it depends on which cost you are. But if you do 4 trips, you're basically already emitting much more than somebody in India will emit over, 3 years. So that is the problem. The problem is that we are faced with contradicting desires. And some of these desires really go against our potential to reduce our carbon footprint, which is how many emissions we do in our life. So this is why climate change is often called the perfect storm, just because it brings so many things together in such a complex way, with so many links that are uncertain and very hard to understand, that it becomes behaviorally very hard for us to do something. So let me sketch out for you 3 levels of response that I think are interesting, and this is where most of the research will be done in the future, and maybe some of you will contribute to this. The first is related to the thinking fast, thinking low conundrum. The second is what I call the ethical response, and the third is how thinking slow then lead us to trading off. So let's start from the first. So what I call the thinking fast of behavioral response. If you only could stop and really think about it every time you do everything, then the problem would be solved. But the problem is that Homo sapiens, so we are not primarily a creature of rational deliberation. That's not what we are. Indeed, we are creatures of habit, and we learn from experience. And what that means in the case of climate change, that's very important, is that we don't experience climate change, so it's very hard to get a sense of what that is. We do experience weather every day, but that doesn't really tell us nothing. And when it's a little warmer, most of us are just happier. So we don't experience and learn from experience what climate change is. It requires you to go on, read books and read the report, for example, that I just showed you. And then we use associations, emotions, and habits to guide our actions. And this is good. Most of the time, this does the purpose, okay? But in the case of climate change, this is just not working. Why? For example, habits and the status quo, that's very bad, because we are starting and departing from a situation where we were born burning fossil fuel. Our life is built around it. So the fact that we are we like the status quo as a species. It's very hard for us to move out of habits. Is playing against us in solving the climate change problem. Emotions, well, that can help you at time, and I'll discuss a little bit in a bit. But most of the time, climate change is not as emotionally intriguing as it could be something else that you would see in the media. That's why you don't see most time on news issues about climate change and new reports by boring scientists, but you see stories about kids that have got lost and then found again their house, because emotionally that's much more interesting. And then, and I go back here at the carbon-free grandmother case studies, we have multiple goals. And most of these goals push us away, and most of these goals are often conflicting. So it's hard for us to keep on track of the change that would be required. So this is a case, so this is an example. What I'm showing you here is Google searches for the word climate change, and an indicator of weather-related disaster. It doesn't really show in the picture, but the point that I want to bring home is that people typically react to weather rather than climate change. React by tweeting or writing about, searching about climate change on Google to, a storm rather than a gradual increase in temperature. And simply because a gradual increase in temperature, you don't really feel it. You don't really go and check how was at this very same day the temperature last year, 20 years ago, or 100 years ago. And if it was 0.5 degrees less, well, who cares? How can I notice that? So it's not denial, I'm just very selective about the reality I accept. And this is so very true and important for climate change. Now, a little bit, these behavioral aspects of human being can be used and has been used in favor of climate change, because you can use then extreme weather events like Hurricane Katrina or others to gain the attention of the public on the problem of climate change. There's no reason not to do that. If you can get people then think more about the problem and learn more about the problem, and you can use this hook. They use it in advertisement. Why not use it for climate change as well? So the message is never waste a good crisis if you can use it, but if you scare people too much and if you don't get a sense of what they can do about it, then it's probably going to backfire. And this has happened with the whole Al Gore. I don't know if you've seen it. It's a nice documentary. It's a documentary by what should have been the President of the United States, Al Gore. And it's an interesting documentary in that it makes everything that you can do wrong in messaging climate change, starting from scaring people too much to exaggerating some of the messages, to the point that it really backfired in the public opinion of the United States, and it created a much larger polarization in the opinions about it than there was before. So I mentioned 3 responses. Let's go to the second response. The second response could be the ethical response. We should stop climate change because it's our duty towards future generation, the past, people who gave us what we have and we have to keep it, etc. This is the narrative of many scientists, but I am afraid it won't work. And the reason why it won't work, at least it cannot work till now, is that ethics is culturally based. And to solve climate change, you have to pull people from many different cultures together. And some of these cultures, for example, might believe that it's not our duty, or we don't have duties for future generations, etc. So Pope Francis just came out with a very important document, and I think that document, the encyclica, called Laudato Si is probably the best example that you can have of an ethical attempt to solve the problem of climate change. And the main arguments are humans should be stewardship of the planet. Alleviating climate change equals alleviating inequality, and poverty is something that we cannot morally accept. And basically, a moral revolution is what will solve climate change. I think this is the best document that you can imagine, and in some cases, the Dalai Lama has also done similar calls for response to climate change. But we will see, maybe this will change the opinion of a large fraction of the population. So far in the US, what it did was only, again, polarizing. People who were believing in climate change before were now even more prone to do something, and people who were denialists before are now even more denialists and think that the Pope is a communist and a revolutionary. So we'll see if it will have an effect, but I doubt we can, base our efforts on that. So the reason why I doubt it will work is that what constitutes your ethical view, if you really go and think about it, is a mix of personal experience, self-efficacy, culture, pro-environment worldview, how much you believe in the fact that free market might solve the problem or not solve the problem, how much knowledge you have of climate change, how old you are, what is your gender, what is your political position, and how much you were able to study. So all these elements will influence your ethical view. So there's no place in anybody where it is clear that we should care about the environment. So I doubt we can go down this route unless we are able to solve first other problems that include allowing education for a larger share of the population and solving the problem of alleviating the problem of poverty. Now, the ethical response, as I said, do not help crossing the tribal divide and not necessarily helps in choosing. It might help defining the fact that we have to do something about that. So on an ethical reasoning, people might agree there is something deep inside that leads us to agree that we have to do something about it. It's unfair that we mess up the planet, but still it doesn't help us in defining how much we should do. So again, I want to take home something good that is very good and that we should keep in mind within the ethical way of reasoning, and that is we should make the process ethical. And with this, I want to go back to the discussion and the explanation I gave you at the beginning about the IPCC process. I think that the ethics of this process are inherently good, and this is very important. So the ethics of the process, the way we proceed in producing the science, disseminating the science, listening to various voices within the scientific process and in the political process of the decision, that is very important. So now let's end up with a third way of responding to the problem, which I deeply believe is the one that will bring us to the result. And this is strongly related to slowing down the thinking, not basing our action and analysis on our instincts or ethical instincts or simply emotional instincts, but basing it on rational thinking, which means slowing down, sitting, reading, looking at what the problem is, forgetting about our cultural beliefs, and really truly trading off benefits of action versus cost of actions. So this means I cannot just simply say, I don't want to mess with the planet, and so we should do everything that we can about it. Because if it comes at a cost, then we might want to do something, but not all that we can do, because we want to devote money for other things, like alleviating poverty, for example. Or we might decide that we do not accept reducing greenhouse gas emissions if that increases the price of food. because that's unacceptable. So to do that, I'm afraid that then you need a good model. Then you really need to stop the thinking and to think rationally about the process. You have to build models, you have to collect data, and you have to trade offs costs and benefits. Actually, you don't need a good model, you need many models. Never trust one model. No model is ever right. But if you have a group of models and you can see what they report as a result of their exercises, and you can pull that information together, then you can start to see the way forward to solve the problem. So to build a model, this is a strange picture. It's a joke. It's the group of people that work in the model that I work with. They have, and this is when I was living for a period, and they wanted to assure me that it would work even though I wasn't there. And you see that obviously that's a joke. But the reason why I'm showing you this picture is that everybody in this picture is coming from a different nature, from a different nation, is coming from a different school. They all have different background, and what they have in common is that they like to share their background knowledge with the others. They accept to talk the language of other disciplines. And so some of them are experts in land, some of them are experts in water management, some of them are expert in economics, others are experts in politics. And pulling their knowledge together allows us to build a model that has the different components, all necessary to look into climate change, because climate change is a problem that is partly related to man actions, so energy decisions, you need energy experts, water decision, political decisions, but then it also relates to how the planet reacts to those decisions, and so you need natural science experts, physicists, and so forth. So that is why it is so beautiful to study this problem, because you have all this expertise that have to talk to each other again in a democratic process. And with these models, what you can do, these are several projections forward, coming from many different models, compose each of them, define and produced by groups like the one that I showed you before. These are projection forwards of emissions. So what would happen if we do nothing? And this probably is the range in purple and gray. And then what would happen if we change the way we behave? And that would be all the groups in orange, yellow, and dark blue. These emissions forwards allows us to explore the future, to see what will happen. How much will it cost? Well, what will happen to other systems, as I was saying? What will happen to the price of food? What will happen to water if we follow any of this path? Where are going to be the criticalities? Are we going to alleviate poverty while going towards this path, or are we going to make the problem worse? And so these models allow us to look into that, but also to answer questions like, how will we go there? What we will have to do to go there? Will we have to invest more in total electricity generation? Will we have to spend more money for renewables power sources? Or should we do it without using too much nuclear, with all the risks that it imposes? And if we use nuclear, where should we expand nuclear, in which countries? So that then it's possible to analyze whether that's politically it's feasible or risky. And finally, they allow us to look into how much damages of climate change will we still have for different level of temperature that we will reach, so that we can trade offs these damages with the costs of reducing climate change, and come to a point where basically these trade-offs gives us a set of optimal responses. Now I show you that picture, but I can what I want to do by showing you this picture, this is again the trade-off. So you have different level of action. Say that I go to put in place policies that allow me to be below 2 degrees Celsius increase by the end of the century, or 3 degrees Celsius, or 4 degrees Celsius. And then what I'm showing you are in red the damages from climate change that policy will imply, and just near it the costs from mitigating climate change that policy will imply. And you can see that by moving towards a more stringent target, which is the 2 degrees, I have a larger costs and more uncertainty about the costs of mitigating climate change, whereas the damage becomes smaller and less uncertain. Whereas if I move to the right, for example, 4 degrees Celsius, where we basically do nothing about climate change, I have very little mitigation costs that are in blue, but huge potential damages. Not only huge in value, but huge in the uncertainty. So it could really be very bad. So with a model, I can provide people who take decision, or lay audiences, or anybody, this information, and then we can discuss collectively where do we want to go. But it's only when we look at this picture and we know where the costs are and where the benefits are that we can make informed decisions. So there will be a debate in the beginning of December in Paris, what is called a debate and negotiation on climate change. It will be very important. This is going to be where the next agreement will be defined. And the negotiators at the tables will have this information in mind, most likely. What would be important is that more of the general population get this information, and so that negotiators can define optimal strategies, which are beforehand debated by the general public. In some sense, this would allow us to move from a situation where basically it is our instinct, our emotions that define what we know about climate change and what we want to do about climate change, to a situation where it's our rational part which really takes part of the debate and define what we would want to do about climate change. With this, I have concluded. I want to thank people who have helped me in putting together this effort, including Carbon Free Grandmother, and have a good day.